So we're asked to find a power series representation of the function arctangent of 3x. So let's think if we can reduce it to a geometric series. And yes, we can, because arctangent is the integral of a function that looks like the sum of a geometric series. So if you don't know how to express arctangent as an integral, what you could do is you could take the derivative and then integrate that. A function is always equal to the integral of its derivative. So let's take the derivative. By the chain rule, I get 1 over 1 plus this squared, so 9x squared, times 3. The derivative of the inside. Now you see that this can be expressed as a power series using the geometric series. But this is not our function. This is the derivative of our function. So I know that my function is the integral of this. Okay? Now let's work to express the integrand as a power series, and then we're going to integrate it term by term. So I already have the 1. I need to see this as a difference. So this is going to be 1 minus 9x squared. And so I have 3 times sum. Remember, I'm using this formula. Where r is minus 9x squared. That's what I get. Now let's write this in a better form, separating all of these terms. So I have negative 1 to the n, 9 to the n, and x squared to the n, power of a power, I multiply the exponent, becomes x to the 2n. And then if I want, I can bring this 3 inside. Okay, good. That's the power series representation of this function, which was the derivative. Now my original function is the integral of this. So now I'm going to replace this by the series and integrate term by term, which is allowed for power series. So this becomes the integral of the series, which is the same as the series of the integral. Let me erase this because we don't need it anymore. Now, this integral is in x. So everything that does not depend on x is a constant, so I can take it outside. So 3 is a constant, negative 1 to the n, and 9 to the n are constants with respect to x. So I'm going to bring them outside. So here, 3. And finally, I'm just left with the integral of x to the 2n. That's just a power, don't be intimidated by the 2n. How do you integrate a power? You just increase the exponent, whatever it is, by 1. So increase 2n by 1, you're going to get 2n plus 1, not 2 times the quantity n plus 1. And then divide by the same exponent that you obtained. N plus a constant, because this is an indefinite integral. Now to figure out what the constant is, so I know I want this series to be equal to my function arctangent of 3x. So I can put a value of x, for example, x equals 0, to figure out what my constant has to be. So if you put x equals 0, you get arctangent of 0, which is 0, has to be equal to this series. So what happens when I put 0 in here? Well, here I'm multiplying by 0 to the 2n plus 1. So the first term, when n is equal to 0, I have 0 to the 1, which kills the terms. And then for every successive value of n, I will also have 0 to some power. So all of these terms are zeros. I'm summing zeros, I get 0. So here I just get constant. So I get that the constant is equal to 0. Therefore, I don't have any constant here, and this is the power series representation that I was looking for.